10 out of 5. So just the 4 questions today. Pause the video, do the questions, and then unpause it. I'm just about to go over the answers. So question 1, when tin oxide is added to water, the pH remains 7. Suggest a reason for that. Now if the pH isn't changing, that must mean that tin oxide is insoluble in water. Okay? Now if it was soluble, because it's a metal oxide, we would expect the pH to be alkaline, because it's a metal oxide. Okay? Question 2, name the products when sodium carbonate and an acid. Now what you need to know, that this is a base because it's a metal carbonate. Remember our 3 bases, metal oxide, metal hydroxide and metal carbonate. And obviously sulfuric acid is an acid, so we're going to get salt plus water. But because we've got a carbonate, yeah, we're also going to get carbon dioxide. Don't forget that. Question 3, calculate the mass of sodium hydroxide needed to make a 200 centimetre cube solution with a concentration of 1.5 moles. So that's our concentration, that's our volume, and we're trying to work out our mass. Okay, so we need to split our page into 2 and put our 2 equations like that. Okay, now one of them we're going to be able to use, the other one we can't. Now we're trying to calculate the mass, so we can't use that, but we do have a concentration and we do have a volume, so we can use that. So our concentration is 1.5 and we times that by 200, but remember it's centimetre cubed, we need to convert that into litres, so divide by 1000 and you get 0.2. Okay, so if we do 1.5 times 0.2, we're getting 0.3 moles. Now that moles can come over. We're trying to work out the mass, so you need to rearrange that to M equals N times GFM. Okay, the moles is 0.3. Yeah, got that from there. And the GFM of sodium hydroxide, hydrogen you should know is 1, oxygen 16, and sodium's 23, but you can use the data book, remember that it is sodium 23. Okay? And if we add that up, we're going to get 40. So 0.3 times 40, getting 12. Okay? 12 grams, that's your answer. This one, very similar, split your page, get your 2 headings, N equals CV, N equals M over GFM. Okay, so 5.5 grams of lithium oxide was added to 350 centimetre cubed to calculate the concentration. So we can't use this one because we don't have the concentration, but we've got a mass, so we can use this one. So our mass is 5.5. GFM we can always calculate. Yeah, so oxygen 16, lithium, use your data book. Lithium is 7. Okay, but there's 2 of them, so that's 14. So that is 30. So 5.5 divided by 30, 0.183. 0.183 moles. And we can transfer it over here, but after concentration, so we need to rearrange it. Yeah, get rid of the volume, bring it down because it's times, we bring it down and we divide. So N over V, so that is 0.183 divided by 0.35 because we've got that, but it's in centimetre cubed, so we divide by 1000 and our answer 0.183 divided by 0.35, there's your answer there. 0.523, and our units moles per litre. Okay, right. What we're going to do, we're going to move on to something called titration. So I'm going to give you a background to this. And then we're going to do some calculations. And then the next lesson, I'm going to see if I could maybe do a titration for you as an experiment. Okay, because usually you would get to do it, but we're not able to. Now, so first thing first, we need to know what a titration is. Okay, now titration is an analytical technique. Analytical technique used to determine the accurate volumes of a solution involved in reactions such as neutralization. Okay, such as neutralization. Now, what we do with titrations, and again I'll explain this in a lot more detail and it'll make a lot more sense when we come back to it next week and you actually get to see what's going on. But in titrations, we normally use an indicator to show the end point of the reaction. Okay, and what we mean by the end point is when we need to stop adding indicator. So when to stop, not a indicator, sorry, when to stop adding the reactant. Okay, so the minute the indicator, there'll be a colour change. Okay, it might go from red to blue, it might go clear to purple, whatever. But when we get our end point, when it changes that colour, that's when we stop adding our reactant. Okay, so I'm going to use a ruler. And I want you to draw a new line here, and we'll call that is known as a white tile. Okay, literally just a tile that's white that we'll place our conical flask on. Okay, we draw just a conical flask like that. So if we label this is our conical flask containing a known volume of an alkali. Yeah, and it also contains an indicator. Okay, now indicator, it could be something like litmus solution. Okay, and basically when that undergoes neutralization, when the pH is 7, the litmus solution, that will turn purple, but you don't need to know that. Okay, just know that the indicator is used so that when the reaction is finished, when the reaction is neutralized, the indicator changes colour, and that tells us. Okay, so conical flask containing a known volume, so we know how much we put in that, and we normally use something called a pipette to measure this out, but again I'll talk about a pipette in the next lesson. And finally, what we have here, this isn't going to be a very accurate drawing, but what we have here, sorry actually they really go that far up, is something called a burette. okay? And the burette, quite a very accurate instrument. It's a burette containing the acid, and normally on the burette we have like a wee tap, like that, okay? And that just allows us to open and close it, and that allows the solution to pour out. Okay, so the burette containing acid, so we've got a conical flask containing a known volume of alkali, and we've got a burette containing acid. Now, we normally just fill the burette up, it doesn't really matter how much is in it, as long as we've got enough. Okay, now the white tile, again I'll explain this in the next lesson, but we use the white tile to see the end point clearly. Okay, to see the colour change. If that's going from, don't know, red to blue or whatever, it's just to, the white background makes it a lot clearer. Okay, and that can come up as a wee question. What could be used to see the end point better? White tile. Right, so what we can do is from this, so from this setup that we've got, from this we can work out how much acid, okay, how much acid from the burette, okay, so that instrument there, from the burette, how much acid is used to neutralise the alkali. Okay, and remember, whatever's in the conical flask, we know how much is in there because we've used something called a pipette, which I'll explain in a later video. We've used a pipette to measure that out. Okay, now, so we'll turn the tap, the acid will go in, okay, the colour change will happen. The second the colour change happens, we close the tap and we measure how much acid we've got. Okay, now what we do is we repeat this. Yeah, we don't just do it once. Yeah, we're scientists, we're chemists. So we repeat the titrations multiple times until we get something we call concordant results. Okay, and what we mean by concordant results is we get results within 0.2 centimetre cubed of each other. Okay, and then once we've got that, once we've got two concordant results within 0.2 centimetre of each other, then we take the average of those two results. Okay, so you need to know, very important that you know this word here, concordant. Concordant results, that's when we're within 0.2 centimetre cubed of each other. Okay, concordant results. Now, what we mean, if I give you an example, okay, if we do our first titer, now the first titer is normally called the rough titer. Okay. The second titer, and then the third titer. So this is the 3 definite experiments. So this up here, we do this 3 times. Okay, so we measure how much acid it takes to neutralise. That's our rough titer. Okay, then we rinse it all out, fill it back up, and then do the full thing again, and we get a second titer, and then rinse and repeat, and we get a third titer. So let's just say we do 3 experiments, and we get 25.6 centimetre cubed, we get 24.5 centimetre cubed, and we get 24.3 centimetre cubed. Now, what some people do is they take the average of all 3, but what you have to do is you have to take the average of the concordant results, the ones that are within 0.2 of each other. Okay, now 25.6 is way higher than 24.5 and 24.3. That's not concordant. Okay, the two concordant results are 24.5 and 24.3 because they are within 0.2 of each other. Okay, now they are the concordant results, so we take an average of them. Okay, so for you that can't remember how to take an average, you add all the numbers up and you divide by how many are there. So 24.5 plus 24.3, and there's two numbers, so you divide by 2 to get an average, and our average will be 24.4 centimetre cubed. So that 24.4, we would use that in our calculations. Okay, we would use 24.4 in our calculations, but I'll come on to that later. Probably not this video, but certainly the next video. Okay? Right. So, we're going to do something now called titration calculations. And I'll give you a wee note on it, and then the best way, you know this, the best way to learn how to do something is just to practice it, go right into an example. Okay, so titration calculations, the good thing is you actually know how to do them already because you've done them. They're very similar to our calculations from balanced equations. Okay, that's the ones with the known and unknown. You split your page into 3. Okay, you get them all ratios. So similar to our calculations from balanced equations, but with a wee twist. This time we use n equals CV instead of n equals m over GFM. Okay, and we do that because as we are dealing with solutions. Yeah, we're dealing with solutions, so we need to look at the volume, we need to look at the concentration of the solutions. Right. So, like I said, best way to do this is just get in about it with a couple of examples. Okay, so question number 1. We're going to do 2 questions. So question 1, it took 12.5 centimetre cubed of 0.2 mole per litre of sodium hydroxide to neutralise 10 centimetre cubed of sulfuric acid. Okay, and our question is to calculate the concentration of sulfuric acid. Okay, calculate the concentration of sulfuric acid. So, what we need to do, oh, you need one more part actually. You need the equation. So this is the equation here. Okay, so we've got 2 moles of sodium hydroxide plus 1 mole H2SO4, and that goes to sodium sulfate plus 2 moles of water. Okay, now what you want to do, I'm going to take my pen, the red pen, so in black that's the question, red this would be your answer, this is how you would answer it. Now with titration calculations, you should be, you focus on the reactants. Okay, you want to focus on the reactants, and that's it. So you write what you know. Yeah, I've always told you that. First things first, you always write what you know. So if we look at sodium hydroxide, what do we know about sodium hydroxide? Well, we know the concentration is 0.2 moles per litre, yeah? And we know that the volume is 12.5 centimetre cubed, but because it's in centimetre cubed, divide by 1,000 and you get 0.0125. Okay? Now, what do we know about the sulfuric acid, H2SO4? Well, we know it takes 10 centimetre cubed of sulfuric acid, okay? Divide by 1,000 to get it into litres, so that's 0.01. And the question is asking us to calculate the concentration. So we don't know what the concentration is, okay? So we've essentially got our known, something we know everything about, and we've got our unknown, something that we don't know everything about. Okay, so we've got our unknown and known. So this calculation is going to work exactly the same way, but instead of using N equals M over GFM, we can't because we've not got a mass, we use CV because we've got a concentration, we've got a volume. Okay, so like what we would do normally, we'd split our page into 3. Now, what should go in the middle? Hopefully you're screaming, the mole ratio goes into the middle. And it's the mole ratio between our known and unknown. So we've got sodium hydroxide and sulfuric acid. And our mole ratio is 2:1. Yeah, we've got here 2 moles of sodium hydroxide because there's a 2 in front of it. And we've got 1 mole because there's not a number. Yeah, if there's not a number, we assume that it's 1. So it's a 2:1 mole ratio. So sodium hydroxide is on the left. Sulfuric acid is on the right. Okay, now, like what I always say, you start with the side you know most about. Now, we know most about sodium hydroxide, so we start here. N equals CV. Working out the moles, always step number 1. Now, our concentration is 0.2, yeah? And our volume is 0.0125. I'll maybe just actually write that clear up. 0.0125. Now, if we put that in our calculator, okay, so 0.2 times 0.0125, we've got 2.5 times 10 to the negative 3, but we want that as a number obviously, so that would be 0.0025 moles. Okay? Now, remember what we do, and I want you to do this, okay? You take your arrow and you drag it into the middle. So 0.0025. Now, because it's a 2:1 ratio, yeah, to go from 2 to 1, we divide by 2. So to go from 0.0025 to here, we need to divide by 2 again. So that goes to 0.0025 divided by 2, which is 0.00125. Okay, then obviously we've got N equals CV, but we always do it in our last box, we always do what the question wants us to do. So calculate the concentration, so we need to rearrange it. Yeah, so we bring the V down, so C equals N over V, and get your arrow in. Remember to get your arrow and you place it in, so that's 0.00125 moles, yeah, from the middle, divided by the volume, which is 0.01, and if we put that in our calculator, we would get 0.125 moles per litre. Do not forget your units. Okay, that's it. That's us. And believe it or not, that's a 3-mark question. Okay, 3 marks for that. And if you combine that with the other one, that's 6 marks. Yeah, and then you've got that EH equals Cm delta T, 9 marks. Average rate, another 2 marks, 11 marks. If you know your calculations, you can really rake up the marks. Now, I'm going to do, like I said, I'm going to do one more example, and then you guys are going to do some questions. So, example number 2. 40 centimetre cubed of lithium hydroxide reacts with 24.0 centimetre cubed of 0.4 mole per litre of nitric acid. Okay, and the question wants us to calculate the concentration of lithium hydroxide. Right, now, this is our equation. You'd always be given the equation. So lithium hydroxide, that's the formula. Nitric acid, you should know because that's one of your three common acids, yeah, HCl, H2SO4 and HNO3, and obviously that would give us LNO3 as our salt, lithium nitrate and water. Okay, it's already balanced, and that's it. Now remember what I said, if it's a titration calculation, you want to focus on your reactants. Okay, the ones that are in the question. Lithium hydroxide reacts with nitric acid. Okay, now first things first, we write what we know. So what do we know? We've got 40 centimetre cubed of lithium hydroxide. Okay, now 40, because it's centimetre cubed, we've got to divide by 1,000, so that's 0.04. And concentration, we don't know because that's what we're asked to calculate. Okay, now what do we know about the nitric acid? We know that we've got a concentration of 0.4 moles per litre, and we know that we've got a volume of 24 centimetre cubed. Now divide that by 1,000, yeah, and you get 0.024 litres. Now we're ready, yeah, we set up our page, split it into 3. Okay, the mole ratio always goes in the middle. And the mole ratio between what? The mole ratio between our known and unknown. So that's LiOH and HNO3. And hopefully you can see that's a 1-to-1 mole ratio. Okay, because there's no numbers at the start. Now, what side do we start at? We've got LiOH on the left and then HNO3 on the right. Now, we should be starting with the side we know most about. Now, if we look at lithium hydroxide nitric acid, we know most about the nitric acid. So we start on the right side this time. Okay, so N equals CV. Now, the concentration is 0.4 and our volume is 0.024. Okay, and if we plug that into the calculators, okay, I've got it here already, but it comes to 0.0096 moles. Now you can check that just to make sure, okay, and once we've got that, we drag that into the middle. Remember your arrow, don't forget, okay, so 0.0096, and because it's a 1-to-1 mole ratio, we're going to get exactly the same. Yeah, 0.0096. Then in the last box, remember the last box, we always do what the question's asking us, which is work out the concentration. So we need to rearrange the equation to C equals N over V. The number of moles, get your arrow, comes from the middle, so that's 0.0096. And the volume of lithium hydroxide is 0.04. So we divide by 0.04 and our answer should be 0.24 mole per litre. And that's it. Okay, another 3 marks, a gift. Okay, so make sure you look over your notes, make sure you know, yeah, what a titration experiment looks like. Yeah, we use an indicator. It consists of a burette, a conical flask, white tile, indicator to show the end point of the reaction. Okay, the conical flask, we know what's in here. Yeah, it's a known volume, and we're trying to work out how much acid it takes to neutralise the alkali that's inside here. Okay, we repeat the titration experiment multiple times until we get concordant results, okay, within 0.2 of each other. And then once we do that, we use that average in our calculations. Okay, so for example, 24.0, that must have been the average calculation. That must have been the average titer value. However, sometimes you're not always given the average. Sometimes you're expected to work out the average in a question, but don't worry, we'll go over that in the next lesson. Okay, right, that's us. Thank you.